Welcome, let's do some more factoring. Now the first one is kind of tricky. It is not, we're not doing factor by grouping with that. There is just no way that you can do factor by grouping and have this work out. However, if you look really carefully, we've just gone over perfect squares in the last video. This is a perfect square. Right? It follows, we've got the it follows that pattern, right? So you would have u squared plus 2uv plus v squared, right? So v is 6, right? Because 6 squared is 36. And u is x, because x squared, I mean, right? U is x. So the middle term here would be 2 times x times 6, which would give you 12x. So this is actually a difference of squares. So if you recognize that you've got a difference of squares, technically, you could rewrite the x squared plus 2x plus 36 as a perfect square, and then it's just square root plus square root minus square root, right? All right, so x squared plus 12x plus 6 is x plus 6 squared, right? X squared plus 12x plus 36 is x plus 6 times x plus 6. Multiplies to give me 36, adds to give me 12, right, is going to be 6 plus 6. And 6 times 6. Right? And so you have x plus 6 squared minus 9y squared. Right? So it's just going to be square root plus square root minus square root. Right? So the square root of x plus 6 squared, of course, is x plus 6. So x plus 6 plus square root of 9y squared is going to be 3y times square root x plus 6 minus the square root of 9y squared. So minus 3y. And there we go, right? We just factored that like a difference of squares. Right? I have got to learn not to put 3 problems on a page. All right, let us try factor by grouping with this one, however. All right, and see if that works out for us. We do have some common terms here. All right. So first to our group, x cubed minus xy squared. And then second to our group, x squared y minus y cubed. See if that works out. Oh, that's not going to work out, is it? Right? Because we're going to end up with y's. Oh, maybe. Oh, no, I take it back. I looked too quickly. All right, we got y's here. I just can't read my own handwriting. All right, let's factor out the x. Our greatest common factor. We have x squared minus, and then x times y squared would be left with y squared. And then a greatest common factor for x squared y minus y cubed is going to be y. X squared y divided by y is x squared. And then y cubed divided by y minus y squared. And look, we have a repeating factor. So we can factor that out. And so we have x squared minus y squared times x plus y. Hey, but what is this but a difference of squares? All right, so let's factor that. All right, so square root plus square root times square root minus square root, and then times x plus y. Well, if you've got 2 factors of x plus y, we could just rewrite that as x plus y squared times x minus y. So these two were kind of similar in that we had a difference of squares, but the difference of squares was a lot easier to see in the second one than it was the first one. All right. Am I going to have enough space? Let's clone the page and do this on the next page before I get halfway through and say, oh, I don't have enough space. All right, clone the page. We'll go to this page now. Whoops. You know, I oriented the board and it's still pretty off. And so I'm going to erase this because we just did those on the other page. And I'll put a little X and put other page. All right, so here I see that we have repeating factors. I've got an x minus 3 here and an x minus 3 here. I've got a 2x plus 1 here, and I've got a 2x plus 1 here. All right, so we can factor those out. All right, now, how many x minus 3's can I factor out? Well, I can factor out 2 factors of x minus 3 because I can't factor out any more than the smallest number, right? So x minus 3 squared, because that's the smallest number of factors, right, is the 2 factors there. And we can factor out 2 factors of 2x plus 1. We will, when we get to our, when we get through our first topic, when we get to calculus, is going to be limits. You know, learn all about limits. But when we get to the topic after that, which is going to take us quite a few weeks, several weeks, you're going to need eventually to be able to factor out. It's going to be really important in a later lesson to be able to factor out repeating binomials. Otherwise, you're not going to be able to solve some of the equations we need to solve. All right, and the solving is actually easy once you get it all simplified out. All right, so we factored out 2 factors of x minus 3, 2 factors of 2x plus 1, because that second term there has 2 factors. And then what are we left with? All right, well, x minus 3 squared divided by x minus 3 squared, that's just a 1. Well, I'm not going to write 1 in there. I'll have 1 times something. I guess I'll write the 1 times something just so you know that x minus 3 squared times x minus 3 squared, that's 1. Right? So it would matter, except it's going to be multiplying, right? And multiplying by 1 doesn't change anything. It would matter if we were adding 1, but not multiplying. But I'll write the 1 in. So 1 times, and if we factor out 2 factors of 2x plus 1, we're going to be left with 2x plus 1. I am really glad I cloned the page because I have to keep moving this over. All right, and then if we factor out 2 factors of x minus 3, we're going to be left with a factor of, well, you know, I need one more parentheses because it's everything in here times x minus 3. Oh, wait, I put that in the wrong spot. Excuse me. Everything in the parentheses here. No, maybe I do have, no, I do have enough parentheses because of the 1. Good thing I put the 1 there. Because now, because I want to multiply everything, you know, everything is technically multiplied by that, right? We're not going to multiply because the point was to unmultiply, to factor. But we want to make sure, oh, I am missing. You know what? I don't think I need them because it's this times, yeah. So long as I end with the parentheses. Sorry. Sometimes I have to really look at my parentheses. We'll make sure we've got all our parentheses closed at the end. All right, back to where we were doing. X minus 3 cubed divided by x minus 3 squared is going to be x minus 3. 2x plus 1 squared divided by 2x plus 1 squared is 1. So long as I put a parentheses there, I'm good, right? We've closed the parentheses, and all of this times all of that, right? So now we've got x minus 3 squared as a factor, 2x plus 1 squared as a factor. The only thing we have left to do is just simplify what's in the parentheses. Well, I don't really need the 1, right, because that's not going to change anything. So this would just be 2x plus 1 plus x minus 3. And if I combine my like terms, I'm done. X minus 3 squared times 2x plus 1 squared times 3x, 2x plus x, minus 2. 1 minus 3. There we go. We're done. All right, so we factor out the repeating factors, and then we combine any like terms, and that's it. Whoops, well, I guess I switched the pages. These two are reversed. This is the one we just did before. All right, factor and solve, and then a factor. And factor 1 is an awful lot like the one we just did. All right, actually, let's do that one first. Let's do the factoring, just to review it. So I've got an x minus 3 and an x minus 3. I've got x plus 2 and an x plus 2. All right, so how many factors of x minus 3? We could factor out 2, right, because that's the smallest exponent. X minus 3 squared. And how many factors of x plus 2? We could factor out only one, x plus 2. All right, and in parentheses there, if we factor out the x, so x minus 3 cubed divided by x minus 3 squared is going to be x minus 3. X plus 1 divided by x plus 1 is 1. We know we don't need it, but I'll put it in just to make sure you understand that. And then here, x minus 3 squared divided by 2 times x minus 3 squared is just going to leave the negative 2. Right, just the coefficient there because all the x minus 3's have been factored out. And then x plus 2 squared divided by x plus 2 is going to be x plus 2. So if we combine our like terms, x minus 3 squared times x plus 2 times, I don't need that 1, x minus 3, I'm going to distribute the negative 2 at the same time, minus 2x minus 4, and then we'll combine the like terms. X minus 3 squared times x plus 2 times, I really have to write somewhere. I think I still have enough space for the other problem on this page. And then we have x minus 2x is going to be negative x, negative 3, plus a negative 4 is going to be minus 7. Right? And if you don't like negative x minus 7, we could factor the negative out. So either one of these is the same. Right? If I factor out if I factor a negative out of negative x and negative 7, it becomes x plus 7, and I can put the negative in front. But they're both good. All right, let's look at the next one. Here's from the solving one. And I've got exponential. How do we factor that? Well, don't think of it as an exponential. All right? Let's let w equal 2 to the x. What would w squared be? Well, that would be 2 to the x squared. And what do we do if we raise power to a power? We multiply exponents. So w squared equals 2 to the 2x power. All right, so this we could use substitution. So it works with things other than just polynomials. It could work with a problem like this, so long as this one here is just this squared, right? So 2 to the 2x is the same as 2x squared. All right, so now we can just rewrite that. So then it'll be a lot easier. So we got w squared plus w minus 12 equals 0. Well, that's a really easy one to factor. We don't even need to factor by grouping by this. Multiplies to give me 1 times negative 12 is negative 12. Multiplies to give me negative 12, but adds to give me 1 is going to be w plus 4 times w minus 3. But we put the w's in, so we got to take the w's out, right, and make that back to being 2 to the x. So 2 to the x, and equals 0. We're solving this one. 2 to the x plus 4 times 2 to the x minus 3. All right, and then we just set them equal to 0. The factors equal to 0 to solve. Right? Zero product rule. If the product of two things equals 0, then the terms have got, one of them's got equal to 0. So we set them both equal to 0. 2 to the x plus 4 equals 0. All right, let's subtract 4 from both sides. 2 to the x equals negative 4. How do you solve an exponential? Take a log of both sides, right? All right, so we have log base 2 of 2 to the, oops, that's an exponent, 2 to the x equals log base 2 of negative 4. All right, so the exponent can move in front, right? So this is x, and log base 2 of 2 is 1. So this is just x equals, and then log base 2 of negative 4. What would we have to raise 2 to get a negative? Not possible, right? You can't take the log of a negative number, right? So this one, right, not a solution. So that one just does not work. So the negative 4 part's not a solution. Oops. Add an extra letter in there. Let's try the other one. Right over here. All right, so we have 2 to the x minus 3 equals 0. So 2 to the x equals 3. Take a log of both sides. Log base 2 of 2 to the x equals log base 2 of 3. All right, this is positive. All right, and this would be x equals. All right, so let's use change of base formula. Log, so it's log of the result over log of the base, or natural log of the result over natural log of the base. That's the exact answer, and that's good enough for me. And that one works out because we're taking the log of a log of a positive number. That's going to be fine. Log of a negative number, we can stop right there. All right, so little review of solving an exponential. Probably got introduced to using substitution with an exponential, and a review of some factoring. All right, so now we're going to, this one is very similar to the last one. We've got rational exponents, and we're going to solve again. However, if we let w equal x to the negative 1, w squared equals x to the negative 1 squared, right? And so that means that w squared equals x to the negative 2. So now we can just rewrite this using substitution. So anytime one is just one variable is just the other, or that one variable is just the other squared, we can use substitution. So now this becomes w squared minus 9w minus 10 equals 0. Nice, easy factor here. W minus 10, w plus 1. Multiplies to give you negative 10, adds to give you negative 9. And then let's substitute back. Always got to substitute back. So that becomes x to the negative 1 minus 10 times x to the negative 1 plus 1 equals 0. And we could now we're just going to set them equal to 0 and solve. X to the negative 1 minus 10 equals 0. Well, I think it'd be a lot nicer if we simplify the negative exponent. 1 over x minus 10 equals 0. Add 10 to both sides. 1 over x equals 10. You just cross multiply, right? Just consider that a 1. So 10x equals 1 times 1 is 1. Divide both sides by 10. X equals 1/10. And then x to the negative 1 plus 1 equals 0. 1 over x equals negative 1. Again, cross multiply. Negative x equals 1, and x equals negative 1. Right? And that makes perfect sense, right? That if I plug those numbers back in, right? We don't really have to check because we don't end up with anything that gives us a zero in a denominator. But if we raise 1/10 to the negative, actually we'll check it just to show you it works out. There's some things we have to check. This wasn't one of them because the only thing that would make 1 over x undefined, or x to the negative 1 undefined, is 0. Right? But if we check, I have 1/10 to the negative 1 power minus 1. Does that equal 0? Well, 1/10 to the negative 1 power is 10 minus 10. Yup. And the same thing here. Negative 1 to the negative 1 power plus 1 equals 0. This is the only one where it's going to be the exact same thing again. Negative 1 plus 1 equals 0. Right? Because if we flip it over, negative 1 over negative 1 is the same as negative 1. So those check out. I won't, if we don't have to check, I'm not going to bother to do the checks on these. I just did it once. All right, so, but here we might have some that we have to check. We'll see. Now, this is another one that we can use substitution with. Right? Because x will let w equal x to the 1/3. W squared equals x to the 1/3 squared. So if we raise power to power, we multiply exponents. 1/3 times 2 is 2/3, right? 1 times 2 is 2. 3 times 1 is 3. So w squared is x to the 2/3. All right, so anytime that variable is just this variable squared, then we can just use substitution. All right, so we have w squared minus 2w minus 8 equals 0. Nice, easy factor now. All right, so what looked like it was complicated isn't complicated. Multiplies to give us negative 8, adds to give us negative 2. It would be w minus 4 times w plus 2, and then just substitute back. So we have x to the 1/3 minus 4 times x to the 1/3 plus 2 equals 0. All right, so x to the 1/3 minus 4 equals 0. Add 4 to both sides. X to the 1/3 equals 4. And then raise both sides. Just cube both sides. Right? If you want to get rid of 1/3 is a cube root. If you want to get rid of a cube root, cube it. So this is x equals 64. And we actually don't have to check it. We're not going to get a false solution on it if we cube something. If it's an odd exponent, you're not going to get a false solution. If it's an even exponent, we would have to definitely check. But if we plug it back in, and you look, the cube root of 64 is 4. 4 minus 4 is 0. So that checks back. And then same thing here. X to the 1/3 plus 2 equals 0. Subtract 2 from both sides. X to the 1/3 equals negative 2. Cube both sides. X equals negative 8. right? And the reason that we know it's going to work out is when you cube a negative number, you get a negative number. It's not like when we raise a negative number to an even power and we get a positive and it makes it seem like it's a solution when it's not. But here, if we plug the negative 8 back in, we would have the cube root of negative 8, that's negative 2. Negative 2 plus 2, that's 0. Right? So you don't have to check on negatives. You don't get on odd exponents. You get false solutions on even exponents. Right? So here, let's rewrite this. Everything has to be on one side. So we have x to the 1/2 minus 5x to the 1/4 plus 6 equals 0, and we're going to use substitution. And you know what? Let's use substitution on the next video, because I want to end this. Those first 2 videos are going to go in the first. We're going to have factoring 1 and 2 nearpods. All right, so I'm going to stop here, and this is going to be on the second video, second nearpod. Bye for now.